So hello to everyone who is watching on YouTube. So I'll start the session in like 3-4 minutes, so a few people can join the session. So since I guess no one has joined the session by now, so I just start the session by like addressing to the YouTube audience. So just to reintroduce myself, hello everyone, whoever's watching. I'm Lakshya Saggi, the Discrete Maths TA for the Tuesday sessions. So in today's session, we'll be solving the problems related to group theory, basically the lectures which are taught in this week, mostly related to groups, what are groups, properties of groups, and so on. So I think this is like the last series of lectures for the NPTEL course. So yeah, I guess I hope you enjoyed the course. So yeah, I'll just get started with the session now. Oh, so hello Hetal. So yeah, just right. So I was just like addressing it since this is being recorded, this meeting. So I was just addressing it for the YouTube audience that today's problem solving session will be related to group theory and stuff like that. So I'm just about to get started with the session. So yeah. So first of all, Hital, I hope my audio is clear, right? Okay. Since you're not responding, I'll just assume it's clear. I'll just start with sharing my screen now. So, oh, cool. It's clear. Nice. So let me just share my screen. We'll start with the problem right away. So just to reiterate myself, so today's problems will be related to groups and like properties of groups and so on. So yeah, I'll just get started. So my screen is visible, right, Hetal? Okay, I'll just assume that it's visible. So just to get started. So the first question is asking which of the following options are true? So basically it's a multiple choice correct question. So it's just saying it has some options like z comma multiplication is a group. So basically all the bunch of options are some like a field and an operator, and it's asking whether this field and this operator is a group or is it not a group. So for checking if something is a group, I'll just list down like, let me just write down this as sort of basic notes. So uh, how to check, like, how do you say whether something is a group or whether something is not a group? So what's the definition of a group? So uh, the for like basically for defining a group, we need the field comma operator to have some properties, the basic four properties. So what are the basic four properties, or maybe the four basic properties? Four properties. Sorry, four properties of a group. So this has been covered in the lectures. I'm just writing this again as like to just remind you of that basic definition, since we'll be using this definition and these properties in the question. So yeah. So the four properties of a group are associativity, uh, closure, uh, existence of inverse, and existence of identity. So yeah, these are the four basic properties of a group. So for something to be called a group, it should have associativity property, it should have closure property, an inverse should exist, and an identity should exist. So I'll uh, I'll not write down the definitions for these four. Like I'll just tell you orally, but I think you guys already know about the what these properties actually mean. So I'll just go about this orally. So associativity means, so let's say like we are checking for an operator plus, and let's say there are three numbers A, B, C. So associativity just means that A plus B plus C should be equals to so basically associativity means like while performing an operation on three operands, the order should not matter. Like the order in order by which I mean like which of the following uh, operation do you reduce first? Like let's say we are given a plus b plus c. So if you add first a plus b, a and b, and then add c to it, it should also give the same answer as first adding b and c and then adding a to it. So this is what you call associativity. So just as a reminder, matrix multiplication is also associative. So basically what this means is like, let's just say there are three matrices ABC. So A times the matrix BC will be equals to the matrix AB times matrix C. So this has been this you guys must have learned in high school also. So I'll not go into detail, but I'll just this is just a basic example for associativity. So similarly, closure property says that so if you take, let's say, two elements A comma B of a group and then apply an operation like let's say plus, then A plus B should also belong to that group's field, right? So yeah. So A plus B should also belong to the group. So this is what you call the closure. And similarly, what is so the four properties of group are it should be associative, it should have like closure property, and there should always be an inverse, existence of inverse. What this means is for every element of the group, there should maybe I should write first existence of identity and then existence of inverse. Okay. So what is identity? So as a so existence of identity is so there should exist an element in the group, uh, and the property of that element should be that if you like, let's say the operation is plus, so there should exist an element x in the group such that a plus for every element a in the group, a plus x should give me a only. So I hope you understand what I'm saying, and like this has been covered in the lectures also. What is identity? So when you take the identity, suppose let's say identity is x. So when you take x and x has one operand and another number, let's say a, b, c, anything as the second operand, then like and the operation is let's say plus, then a plus b, then a plus x should give me a only. Similarly, like b plus x should also give b only, and c plus x should give c only, and so on. So that's what you call identity. So, like let's say the group has multiplication as its the operation, then one is an identity, since like anything multiplied by one is the number itself. And similarly, what is inverse? Existence of inverse. The group should also have inverse. And what do you mean by inverse? Inverse is nothing but every element of that group, like let's say for every element A, there should exist an element A prime such that A plus A prime, let's say the operation is plus, such that A plus A prime should give me identity. So identity was, so like for addition, identity is 0. So for addition on numbers, the identity is 0. So in that case, like what will be the inverse for let's say a number 5? For number 5, the inverse will be like -5. So because like we want 5 plus a number a prime such that this should total to 0, the identity of that group. So 5 plus a prime is equal to 0, then a prime should be -5. So I've just gone through these definitions orally because uh, I think these have been covered in the lecture, so I don't think I need to write them down formally, just giving you a intuitive idea for these. So let's get to this question then. So maybe we'll just go option by option here. So option A, what does option A say? Option A says z comma multiplication. So z is nothing but like just to be clear with the notation. So this z field denotes the set of integers, like positive, negative, all the integers included. And this multiplication is just the multiplication number, like the multiplication operator. So the first option is saying z comma multiplication is a group. So Hetal, hello Aditya. So you have also joined. I miss. So Hetal or Aditya, so what do you guys think? Is this a group, z comma multiplication, or is it not a group? Okay, maybe I'll just start by answering this only. So this is not a group. And why is this the case? Like this z comma multiplication is not a group because for it to be a group, there should be these four properties should hold true, right? Associativity, closure, existence of identity, and existence of inverse. So let's just check each of these properties one by one. So first of all, let's check associativity. So is multiplication associative? Yes, actually multiplication is associative. Since let's say a times, so let's say we are multiplying three numbers a, b, and c, then a into, like let's say we first do the product of b and c and then multiply that resulting product with a, this will be equals to basically first of all multiplying A and B first, and then multiplying it with C. So yeah, so multiplication is associative. So first property actually holds. Maybe I'll okay, so why is this not a group? I'll just write this in terms of these four properties. Yes. So associativity holds. Then the second thing is closure. So mm, one second thing is closure. So multiplication is also actually closed, basically, because multiplication over integers is closed because whenever you multiply two integers, you will get back integer only. So that's the definition of closure, right? Take any two operands and apply the operator, then the resultant should also belong to the field, that field only. So this is also true. As product of two integers is also an integer. So yeah, in fact, second thing is also true. So it also has closure. Now coming to the third property, existence of identity. So does this z comma multiplication have an identity? So actually, this is also yes, we are right, Aditya. This has an identity. One is identity. And why is one identity? As any integer multiplied by 1 gives that integer itself. That is like a times 1 will give back a only. So yes, in fact, 1 is the identity for this. So identity also exists. So now coming to the fourth property, actually, which is inverse, it won't exist. I'll just show you why. So existence of inverse. So this is the property which fails in this integer comma multiplication, and this is why it is not a group. So uh, this would be a no. Inverse does not exist because let's just take any number. Let's just take the integer 2. Let's take a equals 2. Like let's take an element 2 of the group. Then what we can say? Uh, then there exists no integer x such that 2 times x, or maybe let's just say no integer b, because multiplication with x can cause confusion. So 2 times b will give me 1. Because how did it define inverse? For inverse to exist, we said that uh, a number is an inverse it multiply if we obtain the identity back, like for an integer a number a prime is an inverse if like a times a prime will give back the identity of that group. And here the identity of the group is 1, as we have already discussed that 1 is the identity here. So basically what we would want is multiplication is the operator. So we would want another integer to exist from the group such that like 2 times that integer should give me the identity, which is 1. So 2 times b should be equals to 1. From this, actually, we get b equals half, which is not an integer, right? So this is why so there exists no integer such that 2 times b is 1. There exists a rational number 1 by 2, but there does not exist an integer. And we have in option A, we have the field over integers only. So that's why there is no inverse over this group and over this field. So that's why option A is not a group. So I hope you understand what I'm trying to say. So let's get to option B then. So option B says, okay. So Aditya, you have already given the answer in the chat that the correct options are only C, D, and E. And I think you're correct, but like I'll try to go over all the options so that everyone can understand. Uh, Even the ones watching on YouTube, that how is this? So actually option B will also not be a group. I'll not list out all the properties here. So option B is saying like, okay, sorry. I think I put it wrong. So option B is saying field Z is the field. Z is basically the set of integers. So integers comma addition is not a group. So okay, so it's saying that the integer comma addition is not a group, but actually it would come out to be a group. It is a group. And why is this the case? You can check yourself basically that addition also follows associativity because a plus b plus c will give me a plus b plus c only over integers. And also it has closure property because like sum of two integers will also be an integer. I'm talking about like addition. And similarly, existence of identity is also true since for addition, zero is an identity, right? Because a zero added to any number will be that number itself, as I told earlier. And similarly, existence of inverse. So for any number x, minus x would be its inverse, right? Because x plus minus x will give back zero only. And since x belongs to integer, minus x is also an integer. Note that here we have talked about only all integers comma addition, not positive integers. Like suppose instead if the field was positive integer z plus, then associative would hold, create closure would hold, identity would also be there, but there won't be an inverse if we just constrain it to set of positive integers. Because let's say for a number 5, minus 5 should be the inverse. Minus 5 should be its inverse, but minus 5 is not positive. So if we just instead took the field as z plus only, in that case it won't be a group. But since we are taking z as a whole as a field, so it will be a group. Well, so I'll just write down this that it follows all four properties. So, so actually option B is a group, but it's saying in option B that it is not a group. So option B is also false. Now coming to option C. So option C says that set of Q is set of rational numbers. So I hope this notation is clear that Q denotes the set of rational numbers. So set of rational numbers, comma multiplication is a group. So this statement is actually true that it is a group. And why is this the case? You can check this again by yourself that since we are doing multiplication only, so multiplication over set of integers over set of rationals, all the time it is associative, all the time it has closure also since product of two rational numbers is also rational. Similarly, existence of identity. So here also one will be the identity because any rational number multiplied by one will give back the rational number itself. But here inverse will exist. And why is that the case? So in set of integers, we said like let's say we take a number 2, then there is no integer b such that 2 times b is 1. But in set over the set of rationals, there will exist an rational number, right? Which will be 1 by 2. So actually you can say like for any rational number, every rational number can be written in form of p upon q. So for any rational number p by q, there will exist its inverse, which will be actually q by p, right? So I hope you guys understand what I'm trying to say. Uh, so there will exist, I think, inverse. I think in this q comma multiplication, I should not be including the number 0. Only then will it be a group, right? Because for the number 0, uh, like 0 is also a rational number, right? But 0 does not have any inverse. So let's just like you should correct it to like, instead let's take in option C. take it as q minus 0. Consider it as q minus 0. And in that case, it will actually be a group. Why? Because why I'm removing 0? Because for every rational number p by q, there will be an inverse q by p, except for the number 0, right? Because 0 will not have a multiplicative inverse. I hope it's clear to you guys. So, so this follows all four properties. But if we had included 0, but if we had included 0, then it won't be a group, as 0 does not have a multiplicative inverse. So 0 times anything is 0 only, so you can't get any number such that 0 times that number is 1. So I hope this is clear to you. So option C is a group only when we take the field as q minus 0. So similarly, now let's come to option D. So option D is saying that Z, the set of integers, comma minus is not a group. So actually this statement is true that this is not a group. Basically the set of integers over subtraction operation, it is not a group. And why is this the case? You can just check the first property itself, that associative won't hold. It is not a group. It is not associative. It is not associative. That why is this the case? So because, like, let's say we take three integers a, b, and c, then a times b minus c is not equals to. So this is a symbol for not equals to, like, a minus b minus c. So note that subtraction is not associative, and why is this? So suppose we subtract c from b first. So this will be equals to, after opening the brackets, a minus b plus c. But right hand side will be equals to a minus b minus c only. So that's why this is not associative, and which is why this is not a group. So similarly, we can also check, like, it will have in closure, like set of integers over subtraction will be a closure, because subtraction of two integers will be an integer only. And there will exist an identity here also. Okay, I don't think there will be an identity here either, because for an identity to hold, we need to have uh, basically, like, if the identity is x, then what we should have is, like, a minus x should also be equals to a, and x minus a should also be equals to a. So both cases can't be true. So a minus x should be equal to 0, and x minus a should be equal to 0. This is what we should have it if we need to have existence of identity. But, like, if a minus x is 0, sorry, I'm confusing you, but okay, I'll just change this again. So for existence of identity, what we want is a number x, such that for any number a minus x should be equal to a, and also x minus a should be equal to a. This is what we want as identity, right? The number e is an identity if a dot e is also a and e dot a is also a. But here what we'll get is, like, if x minus a has to be equal to a, then x should be equal to 2a. But if a minus x has to be equal to a, then x should be equal to 0. So actually there does not exist an identity for subtraction. So if identity does not exist, there is no existence of inverse either. So, like, these two things will also not exist for subtraction. Like, but you can just straight away say it is not a group based on associativity directly also. So yeah. So now let's just come to option E then. So option C says that the R denotes the set of real numbers. So a set of real numbers over addition is a group. So In fact, this is true that set of a real numbers over addition will be a group. And the reasoning will be very similar to option B, like set of integers over addition was a group, right? We showed that option B is a group, the set of integers over addition. Similarly, this will also be a group. And why will this be the case? It also follows all four properties. So just to check orally quickly. So why will this be a group, the set of real numbers over addition? So we're checking first for associativity. So we know a plus b plus a plus b plus c will give me a plus b plus c. Similarly, closure. So addition of two real numbers will give me a real number itself, right? And existence of identity. So here also, since zero is a real number, so here also zero will be an identity because any real number plus zero will give me that real number itself. And similarly, existence of inverse. So for a real number x, minus x will be its inverse. So that's why it is also a group. So over and all, we have shown that option A is not a group, option B is a group, option C is a group, option D is not a group, and option E is a group. So what statements are true? So let's just write down. So option A says that this is a group, but we have obtained that this is not a group. So A is not true. Option B says it is not a group, and we have obtained it is a group. So B is also false. Option C says that it is a group, and we have also obtained it is a group. So option C is true. Option D is also true, and similarly, option E is also true. So hence options C, D, E are correct. So I'll just underline this also. So yeah, I think Aditya had written this in chat, like A is false, B is false, C is true, D is true, and D is true. So yeah, Aditya, you were correct. Good job. So option C, D, and E are correct. So now let's come to the second question then. Second question is asking, let T be a group of 100 elements. What is the largest possible subgroup of T other than T itself? So, would you guys like to answer this question? This is based on, I think, Lagrange's theorem for groups, or yeah, it's called Lagrange's theorem, I think. Any guesses, guys? What can be the largest possible subgroup size for a group of size 100? Okay, so first of all, I'll just remind you guys something from the lecture. So, what is the order of a group? So, what was the order of a group? Order of a group was like the number of. So order is generally defined for finite group. So I'll just say order of a finite group, the number of elements in the group. So basically, like what is the order of a group? Order of a finite group basically is the number of elements in the group. So finite group in itself means like the number of elements are finite. So yeah, this is an actual number. Let's say the group has 20 elements, so order will be 20. A group has 100 elements, so order will be 100. So here the group has 100 elements, right? So I guess I'll just answer the question. So, uh, since we are given group of 100 elements. So basically what this means is that, okay, sorry for this. So basically what we are given is like, since number of elements is what you call the order. So order of the group T is equals to 100, right? So order of T is equals to 100 because there are 100 elements in T. Now let's just consider any subgroup of uh, consider any subgroup H. Let's say we take a subgroup H of T. Like we want to find the largest possible subgroup, right? So what we'll do is we'll try to show an upper bound on the possible size of the subgroup. Maybe I'll just put this in the next page itself. So yeah. So we are given a group of 100 elements and we want to find the largest possible subgroup. So we'll try to put an upper bound on the largest possible subgroup size. So basically we'll try to bound. So for any subgroup H, we'll try to bound the value of order of H, which is the number of elements of H. Consider any subgroup H of T. Then what we know is you guys have studied this same lecture. I'll not be repeating this. So the proof or anything. So by Lagrange theorem, what does Lagrange theorem say? Lagrange theorem says that the odd if there's a subgroup H of the group T, then the order of H should divide order of T, right? Order of H should divide order of T. So what basically this means is that uh, this implies that so order of H is nothing but number of elements in H. Number of elements of H will be a divisor of 100, right? Because Lagrange theorem says that order of H should divide order of T. Order of T is 100, and order of H is nothing but number of elements of H. So number of elements of H will be a divisor of 100. So what are the possible divisors of 100? Possible divisors of 100. There will be a bunch of them, like 100, 50, and then like 25. We'll also have like 10 and 5 and 2. So yeah, we'll be having 20 also, like 4 also. Similarly, 1 also. So yeah. So yeah, Hetal has answered in the chat and there's also written. So yeah, you both are correct. So Aditya 1 will also be divised and Hetal, you are correct. The answer will be 50. So I'll just get back to this. So yeah, possible divisors of 100 are these. Like there are these 9 divisors 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are these 9 divisors possible for 100. So the number of elements of H will actually be one of these values only, right? So number of elements of H can only be 100 or 50 or 25 or 20 or 10 or 5 or 4 or 2 or 1. So note that the largest possible value out of these is 100. But the question is asking largest possible subgroup other than T itself. So T was also containing 100 elements, and if H also contains 100 elements, then T will be equals to H, right? Because if A is a subset of B and size of A is equals to size of B, then A equals B for two sets. So we won't answer 100 because so I'll just write this down also. Since number of elements of H can't be 100 other as H equals T in that case. Hence, maximum possible number of elements of H will then be, so if it can't be 100, then what's the next highest possible value? It's 50, right? So the maximum possible number of elements of H will be 50 then. So this is the answer. I'll just underline this also. So H, so 50 is the correct answer. So yeah. So yeah, Heather, you are correct. You have written 50 as the answer. So yeah, please the correct answer. Okay. So now coming to this the third question. Third question is nothing but a straightforward revision question for you guys. So what is the generating function for odd partitions of X? So this is nothing too fancy, neither is it too interesting. It's just something which has been directly referred to in the lectures, right? So so what is the odd partitions of X? Odd partitions of X is nothing but a number of ways in which you can write down a certain number as sum of odd numbers, right? And you find that by a generating function, and the generating function for this is given by let's say the generating function is fx. So f of x can be written as, how do you write it as? You just write it as, like, let's say 1 plus x square plus x cube. So what do this first term imply? What does this first term imply? So this first term implies that uh, you are taking the ones basically. So one will denote like you are taking no one. Like one is also odd. So odd partitions, what numbers can you use? You can use one, you can use three, you can use five, you can use seven, you can use nine, and so on, right? So if you use one, then how many ones can you use? It is denoted by these exponents. So one will denote that you are using no one, x, since this is x to the power 0. This x to the power 1 will denote that you are using 1, 1. X to the power 2 will denote you are using 2 ones. X to the power 3 will denote you are using 3 ones, and so on. So you have written this part using the ones. Now we'll also need to use some threes. So how many threes can you use? So you can use either 0 threes, which will be x to the power 0, which will be 1 only, or you can use 1 3, which will be like x cubed, since we are using 1 3. So it will directly contribute a power of 3. And similarly, now if we use 2 3, then we'll write 2 3, we'll write x to the power 6. And if we use 3 3, then we'll write x to the power 9, and so on. And similarly, now we'll go to, like, we have written 1 3, and these are like sums are till infinity. These dots denote these are sums are till infinity, since you can use unbounded numbers for these, right? So now going to like power of 5. So now, how many fives can you use? You can use 0 fives, you can use 1 5, you can use 2 fives, and so on. And similarly, this pattern will repeat like now we'll use sevens now, and then you will use nines. So next term will be 1 plus x to the power 7 plus x to the power 14 till infinity. Then the next term will be x to the 1 plus x to the power 9 plus x to the power 18 till infinity. And this product will also continue till infinity. And now we also know from the lectures how to write these sums. So this is just a GP, like we can assume it to be a GP or anything. So with x as the product which is multiplying, so this can be written as 1 upon 1 minus x only. So this first term will be nothing but 1 divided by 1 minus x. And similarly, the second term will be nothing but, so here only x was multiplying at each term. Here x cube is multiplying in each term. So this will be nothing but 1 upon 1 minus x cubed. And similarly, the third term will be equals to like 1 upon 1 minus x to the power 5. So note that this whole 1 minus x is the denominator. That's why I've written them together. This whole 1 minus x cube is the denominator. This whole 1 minus x to the power 5 is the denominator. And similarly, next will be like 1 upon 1 minus x to the power 7. And this thing will continue using x to the power 9, x to the power 11, so on till infinity. So this will be the value of our generating function. So you can't resolve it further since it's an infinite product. So maybe there are ways to resolve it, but I'll just leave it at that only. That the answer is this, like 1 upon 1 minus x times 1 upon 1 minus x cube times 1 upon 1 minus x to the power 5, and so on. So this is the correct answer. Maybe I'll not underline it since it becomes a bit messy. I just bold this answer. So yeah. So I hope this is clear to you guys. So let's move on to the next question then. So fourth question says that for a path graph P7, so what does a path graph mean? I hope you all remember the definition. So path graph is nothing but a linked list, let's say, of 7 lengths. So which just means like there are 7 vertices which are connected in a line. Let's say the vertices are V1 to V7. So I'll just write now. Uh, P7 uh, or maybe okay, I'll just P7 is a graph of 7 vertices in a line. Like a linked list. So what does this mean? Let's say the what's a V1 to V7. Then there's an edge between V1 and V2. There's an edge between V2 and V3, V3, V4, V4, V5, V5, V6, and V6, V7. So only these are the 6 edges, right? So now we want to see in how many ways can we color this graph with 4 colors such that no two adjacent nodes have the same color. So now this is, so let's say the vertices are V1, V2 till V7, right? So now what we want to do is we want to color these vertices, these V1, V2 up to V7, such that no two adjacent nodes have the same color. And we are given 4 colors. Let's say we are given 4 colors, C1, C2, C3, C4, right? And now what we want is we want to color these V1 to V7 such that no two of these vertices have the same color, adjacent vertices. So basically, we want to color such that V1 and V2 should have a different color. V2 and V3 are adjacent, so they should have different colors. So V2 and V3 should have different colors. V3 and V4 should have different colors. V4, V5, similarly V5, V6, and V6, V7. Note that V1 and V3 can have the same color because there is no restriction as there is no edge between V1 and V3. The only restriction for V3 is that it should have different color from V2 and V4 and stuff like that. So yeah. So first of all, like just as a warm-up exercise, I'll not write this down even, but I'll tell you guys. So suppose this constraint was not given that so that no two colors have the same color. So the question was just that for a path graph P7, in how many ways can you color this graph with 4 colors? Then what would be the answer? It's a very straightforward question. Suppose this part was not there, highlighted part. The question was only this for a graph of P7, how many ways can you color this graph with 4 colors? Any node can have like any two nodes can have same color also or anything. So I feel that you guys can answer this easily. So can someone try to answer this in chat? Like there are basically 7 vertices in this graph. So in how many ways can we color this graph with four using 4 colors only? Okay, I guess no one is responding. So yeah, if this was the only question, so the answer would be pretty easy, guys. The answer would be 4 to the power 7, right? Because there is no restriction for any vertex. So every vertex can have 4 colors, has choice between 4 colors, and there are 7 vertices. So the answer will be like first V1 has 4 choices, V2 has 4 choices, V3 has 4 choices, and so on. So the answer will be 4 to the power 7. In that case, if we were only given how many ways can we color this with 4 colors? But now we have an additional constraint which says that no two adjacent nodes should have the same color, right? So now we actually want to calculate this. No two adjacent nodes have the same color. We can here also like proceed in a similar manner as we counted earlier. So how we can say? So so basically we'll just count choices for each vertex. Okay. So let's just start counting for choices for each vertex. So V1 has 4 choices. initially, when we have not colored anything, we start coloring. So V1 is on the leftmost side. So till now, no vertex is colored, right? So when we start coloring, first start first start coloring V1. So V1 will have like four choices for colors, and then like V2 will be having so V2 will only have three choices then. And why is this the case? Because V1, suppose V1 gets the color red, then V2 can have any color except red. So basically, so if there were four choices for V1, like there were total four choices, so then V2 will only have three choices because the fourth choice would already have been taken by V1 only. Similarly, V2 has three choices, and after that, V3 will also have three choices because like V3 V3 should have a color different from V2, right? So V3 will have the choice of choosing a color which is different from V2. So it has also three choices. And similarly, like V4, V5, V6, V7 also have three choices each using similar reasoning. Because V4 should have a different color from like V3, and then V5 should have a different color from V4, and so on. V6, V7, all have three choices. So I think this sort of problem has been covered in the lectures also. So this is something revision based only. So hence answer will be equals to four times. So V1 has four choices, and each of these V2, V3, V4, V5, V6, V7 has three choices each. So it will be three times three times three times three times three times three, because for each of these V2 to V7, there will be three choices each. So it will be something like there are these six vertices, so 3 to the power 6. So this would be our answer here, right? So I hope you guys understood why will this be the answer. So because like V1 will have the leftmost vertex, which we start coloring, will have four choices for the color. And as soon as we have colored it, we now only have three choices for the second vertex, and then three choices again for the third vertex, and so on. So initially, we think that we haven't colored any vertex at all. Now we are starting to color them. That's why we can color V1 using any of these. We using any of these except the one used by V1 and so on. Yeah. This was the answer. So now let's come to fifth question. So fifth question says, what are the elements of Z7? So Z7 is nothing but the set of integers modulo 7. And what modulo 7, what does it mean? It means the set of remainders when divided by 7. So what would be the elements of Z7? So it's also a basic revision based question, I would say. So uh, would anyone like to answer this in chat? Uh, what will be the elements of Z7? Like what when you decide when you divide a number by 7, what are the possible remainders on division by 7? Maybe this is too trivial a question. I'll just write it directly. So Z7 will be nothing but the set 0, comma 1, comma 2, comma 3, comma 4, comma 5, comma 6. And why is that? Because any number, when any integer basically when divided by 7, will leave a remainder between 0 to 6. This is basic division lemma, right? That anything can be written as like quotient into divisor plus remainder, where remainder is less than divisor and greater than equals to 0. So here the possible number will be like less than 7 and greater than equal to 0, which will be nothing but like 0, 1, 2, 3, 4, 5, 6. So yeah. So in general, any Zn can be written as 0, 1, 2, 3 up to n minus 1. So, yeah. So now let's come to sixth question then. So what does the sixth question say? Sixth question asks, which of the following statements are true? So it has three statements and it's saying which of the following statements are true. So let's just go through the statements one by one. So what does statement one say? So statement one says that operations of a group and its subgroup can be different. So basically, uh, what is a group? A group is nothing but like a set of and a bunch, basically a set of operands and an operation defined over it, right? So it's saying the operations of a group and its subgroup can be different. So is this statement true or false? So yeah, this statement is actually false because like subgroup is defined as a basically in the definition of subgroup only, it's written that we take a subset. A subgroup is nothing but a subset of the group defined over the same operations. So as a subgroup is defined as a subset of the group over the same operation only. So that's why, like, if addition was the operator of the group, then subgroups will also have addition as the operator. Like, this is not a technical question, more of a definition based question. Like, this is the definition of a subgroup. So, yeah, I hope you guys understand what I'm trying to say. That is, there is a difference between like something being in the definition itself or something being derived from something. So, this is just a definition of a subgroup that the operation should be same as the group. Like if someone had defined it in a different way, then maybe it could have been the answer to this statement would have been changed. But for now, as the definition stands, this statement is false. So yeah. Now statement two says Q is nothing but a set of rational numbers. So set of rational numbers over addition plus is addition. Set of rational numbers over addition is a subgroup of R is real numbers. So it is a subgroup of real numbers over addition. So first of all, to check whether it is a subgroup, we need to first of all check whether this follows all the four properties of the group, right? So like the set of rational numbers over addition, will they form actually a group? So I think we had already shown in like first question that option C, like set of rational numbers over multiplication is a group. So similarly here also we'll be able to see, you can just check that uh, this will also this will follow all the four properties of the group. And why is that? Because like addition is associative and it is like two rational numbers when added will give me a rational number only. And similarly, the third property like existence of identity. So zero will be the identity here and fourth is existence of inverse. So for any number p, any rational number p by q minus p by q will be its inverse. So yeah, this will follow all four properties of the group. And since the set of rational numbers is a subset of set of real numbers, like this is something which you guys should know. Like rational numbers is a subset of real numbers, right? So this follows all four properties of the group, and it is also the subset of R. And both and in both the cases, the operation defined is the same, the addition operation. So yeah, so it is a subgroup. True as Q is a subset of R and Q comma plus follows all four properties of the group. So yeah, so note that we checked three things for this statement to check whether it's a subgroup or not. We checked whether this follows all the four properties of the group. We also checked whether the this is a subset of the actual group. So we check that whether rational numbers is a subset of real numbers. And the third thing which we checked was that the operation defined should be the same in the group as well as the subgroup. Like which was a statement one, which was saying that operation of a subgroup and subgroup can be different. It was false, so they can't be different. So we need to check whether both of these operations are same, and yeah, both are additions only. So yeah, by these three things, we can say that it is a subgroup. So now let's come to statement 3 then. Statement 3 says a group under addition modulo n. So what is the modulo? Uh, so like what is a group under addition modulo n where n is prime cannot have a subgroup except for a trivial subgroup identity element alone. So what this statement is saying is, let's just take any subgroup. So this statement is actually true, and I'll just write down how. So consider any group Zn. So this is the statement is considering any group Zn since it's saying like addition modulo n. Uh, mo so yeah, so this is the group it is taking. So addition modulo n. So this is how we can denote it, right? And this plus is also modulo n only. So let's just say like 7. So this addition means like if we want to add 7 and 8 over n, we'll take instead like 7 plus 8 mod n. I believe this has been covered in the lecture, so I'll not go into too much details. But yeah, so it's saying suppose we consider any group like Zn comma plus. So any group under addition modulo n, and where n is prime also. N is prime. Then it's saying that this group cannot have a subgroup except for a trivial subgroup identity element alone. So it's just saying that this group, like this Zn comma plus, cannot have a subgroup except for trivial subgroup, which is identity element. So here identity element will be 0. So one possible subgroup here is just the element 0 and the plus operation defined over it. So that is a trivial subgroup. And what this statement is saying, except for the trivial subgroup, which contains identity element alone, there exists no other subgroup for this group. So for this Zn comma plus, where n is prime, there will not exist any subgroup. So we need to show that. So any idea how can we show this, guys? First of all, are you able to follow? If you have any doubts, like you can ask me in chat, I'll try to answer them. If not, I'll just proceed with the solution for this. Okay, so since no one is answering, I'll just assume everyone understands everything till now. And I just proceed from here. So what this is saying is, so we have any group which is nothing but like Zn, which Zn is nothing but like 0, 1, 2 up to n minus 1. And n is prime here. So note that order of this group will be equals to the number of elements in this group, right? And the number of elements in this group is actually n only, because there are n numbers which are 0, 1, 2, 3 up to n minus 1. So these are n numbers. And we also know that n is prime. Also, we are given that, okay, maybe not. So we are also given that order of this group is n, right? Or the Zn group. And now what we want to say is that this group cannot have a subgroup except for the trivial subgroup, right? So let's just suppose there exists any other subgroup, right? Consider any So this is something like proof by contradiction. Let's assume a non-trivial. So a non-trivial subgroup is something like which does not contain just the identity element or exactly the group itself. So Zn comma plus is also a subgroup of Zn comma plus, but that is also a trivial subgroup. So yeah. So let's assume a non-trivial subgroup H exists, right? So then we know that so since H is not trivial, so H should not have its order as 1 because order 1 is nothing but the identity element, and it should also not have order n, right? Because that will be the original group itself. Then order of H basically the number of elements of H will be greater than 1 and less than n. Right? Because if it was equal to n, then it would be the group itself. And if it was equal to 1, then it will be the trivial subgroup identity element. So yeah. So from this, what we can say is, so basically order of H lies between 1 and n, right? And also, since H is a subgroup, so by Lagrange theorem, so Lagrange theorem is a very important theorem, guys. Keep that in mind. Like it is very useful in a lot of proof. So by Lagrange theorem, what does Lagrange theorem say? That yeah, for a subgroup to exist, its order must divide the actual group's order, right? So H is a subgroup. So basically, an order of the original group was like, let's say n. So n should be divisible by order of H. So I hope this is clear. Like, so order of H is a number between 1 and n. And as H is a subgroup, so by Lagrange theorem, n should be divisible. N is nothing but the order of the original group. So n should be divisible by order of H, right? But n is prime, right? We are also given that n is prime. We have to use the fact. But n is prime. Hence, it only has. So what is a prime number? A prime number is some number which has only the divisors as 1 and the number itself. So it only has the divisors as 1 and n only. So since n is prime, it only has divisors 1 and n. So order of H should either be 1 or n. So order of H should be either 1 or n, which is a contradiction. Since we had originally said that order of H should be between 1 and n, since H is not trivial. But what we have obtained is as n is prime, so order of H should be exactly 1 or exactly n. So these two statements, one which says that order of H should be between 1 and n, and other says it should be exactly 1 or exactly n. So these two statements contradict each other. So yeah, so there can't exist a non-trivial subgroup H. So I hope you guys understood what I meant by this. So so there can't exist a non-trivial subgroup for the given group. So note that the main property which we use for showing this like non-trivialness was that n is prime, right? And that's how we said if n is prime, then it only has divisors 1 and n. And so the order should be either 1 or n. And in both cases, the subgroup is not trivial. So actually Zn, the addition under modulo n does not have much relation to this. So any group containing like prime number of elements, like if order of group is prime, then there can't exist a non-trivial subgroup. So this is a general statement, like not just for a group under addition modulo n. It is a general statement that for a group whose order is prime, there can't exist a non-trivial subgroup. So yeah, I hope you guys understand what I'm trying to say. So yeah, so that's why this statement is true that this group cannot have a subgroup except for trivial subgroup. So statements 2 and 3 were correct. Hence, statements 2 and 3 correct. Okay, so let's just come to the next question then. Any doubts till now? If you have, you can ask in chat, as I always say. So if not, let's just proceed to the next question. So next question says, so this is also a revision based question only, not too difficult. So it says like state whether this statement is true or false, and the statement is quite simple. PDN. So PDN, if you remember from the lectures, was nothing but the partition number for n. So basically, PDN just denotes the uh, part partitioning of n, right? How can you write n? How can you write n as sum of some numbers such that no number is repeated twice, right? So let's just assume like if you have 5, so 5 can be written as, let's say, like 0 plus 5, or 1 plus 4, or 2 plus 3. So we can't repeat any number. So PDN was something like this. You guys must have seen this in lectures also, so I'll not write down the definition. But it was something. PDN was basically the number of ways of writing a number n using the numbers from 0 to n exactly once. Like if you use a number, you can use it at max once. You can use it 0 times also, but you can use it 1 time. So yeah. So number of ways of writing n using integers from 0 to n by using each of the integer at max once. So yeah. So this was PDN. So the statement says that PDN is the coefficient of x to the power n in the function 1 plus x, 1 plus x square, 1 plus x cube, and so on. So yeah, actually, this statement is true. Why? Because like, what would be the coefficient of x to the power n? How it denotes here is like 1 plus x term will denote, like it can be thought of as x to the power 0 plus x to the power 1. So in x to the power n, it will contribute a factor of whether we are including this one. X to the power 0 will denote that we are not including 1, and x to the power 1 will denote we are including 1. So number of ways will be like number of ways if we don't include 1, and number of ways if we include 1. And then in second part, 1 plus x square will be if we include 2 or don't include 2. Similarly, if we don't include 3 or include 3, up to like if we don't include n or include n. And the sum should come up to n. So that's why we are taking the power of x to coefficient of x to the power n. So I hope this is clear. This is straightforward from the lectures only. So this statement is actually true. Because like so this first term 1 plus x term denotes whether you're using 1 or not. 1 plus x squared denotes whether you're using 2 or not. 1 plus x cubed denotes whether you're using 3 or not. And similarly x to the power n. So yeah. So let's come to the eighth question then. So eighth question is, so guys, I'll really want you guys to answer this question because I have done this sort of question like twice already, like using Lagrange theorem. So A's question is, let A be a group of 70 elements, then A cannot have a subgroup of cardinality C. So Aditya is saying that answer is C option, which is 20. So yeah, Aditya, you are correct that this will be the correct answer. So good job. So yeah. So question is asking that the KS is also written C. So yeah, KS. Your answer is correct. So A is a group with 70 elements. So it's asking that which of the following values A cannot have as the subgroup. So which of the can A cannot have a subgroup of cardinality? What? So we just need to find which of the following like cardinalities is not possible for the subgroup. So we know by Lagrange theorem that if there is a subgroup, then its order, like order is nothing but the cardinality only. So its cardinality should divide the cardinality of the original group, right? Cardinality of original group is 70. So order of the subgroup should be a divisor of 70, right? So let's just go option by option. So 5 is a divisor of 70. So it can be a possible subgroup. 10 also divides 70 since 70 by 10 is 7. So it is also groups. 35 also divides 70 as 70 by 35 is 2. But 20 does not divide 70, right? Because 70 by 20, like, it is not perfectly divisible. So yeah. So good job, guys. Answer is option C. And by Lagrange theorem, the order of subgroup should divide order of the group, but 20 does not divide 70. So yeah, nice. So now next question is, so Z6 comma plus is a group. So Z6 is nothing but uh like modulo 6, like integers modulo 6. So Z6 will be nothing but 0, 1, 2, 3, 4, 5. So it's saying, so let's just take this 0, 1, 2, 3, 4, 5 over addition. So modulo addition, right? So this is a group, right? Because like you must have studied this in lectures also, that Zn comma plus is a group because it has the closure properties, it has associativity, it also has like inverse, here inverse, like inverse as well as identity. Like identity is 0 and inverse we have to identify for like 4 in this question. So uh, any guesses, guys? Like this is also straightforward. So uh, what will be the inverse of 4 in this group? So first of all, so KS has written the answer as 2. So yeah, KS, you're correct. Good job. So first of all, let's just identify what will be the identity for this group. So this has been discussed in the lectures also, but whenever we are trying to identify the inverse, first we should be clear what is the identity. So just stating it again, identity of the given group is equals to 0 because any number plus 0 mod 6 will be that number itself. So yeah. Uh, so now as as 4 plus 2. So let's just check, like KS has written the answer as 2. So let's just check whether 2 is correct or not. So as 2 plus 4 mod 6 will be equals to 6 mod 6, which is 0. So yeah. So basically like identity of the group is 0. So we want a number x such that 4 plus x mod 6 is 0. Or maybe I should write this only, right? So we want a number x such that 4 plus x mod 6 is 0. And 4 plus x mod 6 is 0 will mean that from this you can easily see that uh, x will be equals to 2. So, and why is that? So you might think that 4 plus 6 mod 6 is 0. So you might try that like directly put 4 plus x is 0. But from that you will get x as minus 4, which would be incorrect because minus 4 does not belong to Z6. But instead, like 4 plus x, if you put equals to 6, like 4 plus x mod 6 equals to 0 just means that 4 plus x should be divisible by 6. So it can be equal to like 0 or 6 or 12 or anything. If it's equal to 0, then we get x as minus 4, which is not a part of the group, so that is not the inverse. But if we put it equal to 6, then we get a value of x equals to 2. So yeah, so that's why like x equals to 2 is the inverse of 4 in this group. Similarly, like we for inverse, we should also ensure that like along with 4 plus x mod 6 is 0, we also should have x plus 4 mod 6 is 0. Right? Because in inverse, we need to check both the ways, like a plus b and b plus a. But here you can see that since 4 plus 2 is equals to 2 plus 4, so it won't make much of a difference. So yeah, so answer is x equals to 2 only, like 2 is the inverse. So yeah, good job here. So yeah, this is the correct answer. So any doubts for this, guys? Aditya or Hital, do you guys understand? Okay, cool. So this is the 10th question. Then let's come to the last question for the day. So yeah, I think we have, I don't know, maybe the questions were easier or something, but we are a bit ahead of time. So yeah, doesn't matter. You guys can ask me doubts after this if you have any, or we can just close the session early. So 10th question is saying, given a complete graph with 11 vertices, in how many ways can you color this graph such that no two adjacent vertices have the same color? And we are given 26 colors. Okay, so any guesses? So what this question is saying is we are given a complete graph with 11 vertices. So complete graph means like every pair of vertices has an edge between itself, right? So now we want to now we want to answer the query in how many ways can we color this graph so that no two adjacent vertices have the same color. So first of all, let's just see what this question means. So we have a complete graph since. Okay, so KS has written the answer as 26 times, 25 times, 24 times, 23 times, up to 16. So yes, KS, I think your answer is correct. Because like, yeah, it will be 16 or 15. Yeah, it will be 16. Yeah, so your answer is correct. So good job, KS, but I just explain it for the sake of others also. So let's just see. Okay, so I think the straightforward, this question, this sort of thing has been done in the lectures also directly, has been covered in the lectures directly also, but I'll just mention this again just as sort of revision or something. So yeah. So given a complete, so we have given the complete graph with 11 vertices. So what complete graph means is that every pair of vertices has an edge with each other. Since the graph is complete, every pair of vertices has an edge between them. Have an edge between them. So what this means is that every vertex, since no two adjacent vertices should have the same color, and all of the vertices are adjacent as we have just seen. So what this means is that every vertex should have a different color, right? So the problem just reduces to assigning 11 different colors to the 11 vertices out of 26 colors. So what we need to do is we need to basically assign 11 colors to the 11 vertices. So there are 11 vertices, so we need to assign 11 different colors to these vertices out of the given 26 colors. So this is the problem, straightforward. So how can we approach this? So first vertex, since first of all we are starting with a uncolored graph. So first vertex can be like, first vertex will have like 26 choices for the colors. Has 26 choices because like no vertex has been colored till now. So after color, so first vertex has 26 choices for color. So after this, second vertex will have only, because like first vertex will take away one color, second vertex will be left with like 25 choices. And similarly, like third vertex, when you come to like third vertex, so two colors have been taken by first and second. So only 24 choices will have been left. And if we go on, so we'll see that 11th vertex will be left with only 11 choices. So, okay, not 11 choices, sorry, 16 choices. And how can you see like first vertex has 26, second has 25. So like 11th will have like 26 minus 11 plus 1. So which will be nothing but 16. So hence, so total ways will be nothing but product only. Total number of possible ways is equals to 26 times, 25 times, 24 times till 16, which Aditya has also written in chat, which is nothing but 26p11. So it's 6p11 because this is nothing but like 26 factorial upon 26 minus 11, which is 15 factorial. So it will be nothing but this 26 only. or 216 maybe. So yeah, this is the correct answer. Good job, guys. So these were the only problems which I had planned to discuss for today. So yeah, I guess since we have like quite a bit of time left now, like 30 minutes, right? So if you guys have any doubts, maybe you can ask them to me via chat, or like maybe I can just solve any other question which you had in mind, or help you guys with anything related to the course or anything. Or if you don't have any question, like you can also leave the meeting. Like what I plan to discuss is already over. So I'll just keep the meeting on for further like 10-15 minutes. So if any question comes through mind for you guys, like you can ask that question to me. So, but at least from my part, like I'm done for the day, like asking all the questions and all. So now if you have any doubts, you can ask them. Otherwise, like I hope you guys enjoyed the session. So the next session will be like next Tuesday. So I'll hope to see you guys next week also. So yeah. So I'll just stop sharing my screen. If anyone has any doubt, maybe I'll just start it again, or maybe I'll just leave it on. If you have any questions in what we have discussed today or anything which we have discussed in past, you can ask me. Otherwise, you can also leave. Thanks, guys. Thank you for joining. I'll just be leaving the meeting on for 10 minutes. So if any question pops into your mind, you can ask me, else you can leave also. Okay, so since no one had any questions and everyone has left, so for the YouTube audience, I'm just saying that I'll be closing this session. So thanks for watching the session, guys. So bye bye.